Hi guys, so today we'll discuss this question combination sum which says you have been given with different denomination coins, okay? So you have been given with different denomination coins and you have to basically create a combination as such that the sum of that particular combination sums up to 9. I mean the particular target that you have been given. In this case, it'll be 9. Okay, so like if we consider this example, the coins that we have been given with is 2, 3, 4 and 8 and our target is 9. Okay, so now what could be the possible combinations that we can have? One more thing to note here is, let's assume that you have infinite supply of the coins here, okay, for each denomination. So you can choose 2 as many times as you want. You can choose 3, 4, 8 as many times as you want. Okay, so if we consider this example, what could be the possible combinations? The possible combinations could be 2 comma 2 comma 2 comma 3, right? Right, because 2 plus 2 plus 2 plus 2 plus 3 sums up to 9, right? This is what we need. Another such combination that we can form is 3 comma 3 comma 3. This also sums up to 9, right? Another combination that we could have is 2 comma 3 comma 4. This also sums up to 9. So basically this is what you'll have to return. You'll have to return basically all the combinations which sum up to the particular target. So now if you think how we can proceed with this, what is the first thing that comes in your mind? The first thing that should come in your mind is recursion, right? Why? Because you can try out all the combinations, right? And whichever combination which sums up to this particular target, you can consider that, right? Exactly. So now what you can do, let's see how we can use recursion in this. So let's assume we have this 2, 3, 4, 8, right? So now what choices do we have at our hand? Let's assume I'll consider these 0, 1, 2, 3. I've done the indexing for these. So what choices do you have? The choices that you have is that you can choose 2, 3, 4, 8, any number you can choose, any coin you can choose, right? So let's assume the first time we choose and the target is 9, right? Okay, so the first time you can choose the 0th index, the element at the 0th index, right? So what it will be? It will be 2, right? Currently you have 2. So now what you have to look for? Now, if you've already chosen 2, so now your target doesn't remain 2, right? You already have 2. You have to look for 9 minus 2, that is 7, right? So can you choose 2 again? We can choose 2 again, right? Because currently our sum of this particular combination has not reached the target, right? So if you choose to choose it again, what will it be? It will be 2 comma 2, right? Now if you have chosen 2 again, what will be the target? The target will further reduce by 2, it will be 5. Okay, choose 2 again. You can choose, right? Why? Because 2 is less than the target, right? And again it is not reached the target yet, right? So you choose 2 again. So you choose 2 again. You chose 2 again. So if we consider this, what is your target now? It is further reduced by 2. 5 minus 2, that is 3. Now can you choose 2 again? Yes, you can choose 2. So you would decide to choose 2 again. 2 comma 2 comma 2 comma 2. Alright, now what is your target that you have to find? It will be 3 minus 2, right? It will be 1. Now can you choose 2 again? Can you do that? Think logically. You have the target to find as 1. Okay. I mean one more element you have to choose, which is having the value as 1. If you choose 2 again, what will be the target that you'll have to find? It will be 1 minus 2, right? It will be minus 1. Is it possible? It's not possible, right? So if it's not possible, what does it tell us? It tells us that if it's not possible, you'll have to backtrack, right? So basically this won't give you the answer. You'll have to backtrack. Now if you backtrack, what you'll do? I'll just rub this out. Okay, you already chose the 0th element and it was not yielding you the answer, right? Now what can you do? You said, okay, I have already chosen 0th index element. Now what other choices did you have? You could have chosen 1, 2, 3 again, right? So if you choose 1, the element at the first index, what will be the sum? The target is now 3 minus 3, that is 0. The moment it reaches 0, the sum reaches 0. What can you say? You can say, right, that you have found one particular index one particular combination, I'm sorry, one particular combination that sums up to this particular target, right? So this is one of the answers. This is one particular combination which is like which is basically resulting to this particular sum, this particular target. So you can consider, okay, fine, this is one particular combination. Now after this you can so now if you consider this, when will your recursion stop? Can you think of a base case? So what will your base case be? I think your base case should be whenever your index reaches this particular, if it has exhausted all of the elements in it, will it not be the base case? It will be the base case, right? So let's consider for 0, not possible, right? For 1, not possible. For 2, not possible. For 3, not possible. So particularly it has done it for all of the indexes that will be there. And now you can say that this particular combination, if you consider this combination, and if you further try to increase the tree, it will not happen, right? So what can you say? You can say you have been like you have one particular, sorry, you have one particular combination, right? So you'll include this in your, you'll include this in your answer. Okay, now again what can you do? You can go back and you can check again. So you have already formulated one answer. What can you do? You can go ahead and try another things. Okay, for one, this particular, for 2 comma 2 comma 2, 0 and 1 is completed, right? 0 and 1 is completed. What you'll do next? Let's assume 0 did not give us the answer. Okay, and 1 gave you the answer. Okay, you saved it. Okay, you saved it. Now after that what will happen? You'll try again for 2, right? 2 again, you'll try for the index that is present at the element that is present at the index 2. So if you considered 2 comma 2 comma 2 comma 4, it would have not yielded you the answer. Why? Because choosing 4 will again exceed your sum than the target, right? So obviously this is also not yielding you the answer. So you say, okay, this is not yielding me the answer. Okay, now you try to choose the element that is present at the fourth index. If you choose 8, again this will not yield you the answer. And what can you say then? Okay, fine, this is not yielding me the answer. So if you have generated all the possible, you have chosen all the particular indexes, you have exhausted all the elements, you can see, right, that this particular subtree has already been completed. There are no other choices left, so you can go back. You have to go back and you need to try for this particular combination 2 comma 2, and you need to try and see what will happen if you try to include other elements in it. Okay, so let's see, I'll run this. Okay. So if we consider this 2 comma 2, what are the choices that we have? Similarly, you will do this for the whole tree, right? If you complete doing this for the whole tree, you will be definitely guaranteed with all the combinations that sum up to the particular sum. Just like this. Like if you exceed the target, you have to go to other indexes and check. If you exhaust all the indexes in that particular iteration, you have to trace back, right? You have to trace back and try another combination. So that's exactly what we have to do. So now let's get into the implementation of it, right? So if we consider its implementation, then what can be done? What all do we need first of all? We obviously need an index, right? We obviously need an index. What else do we need? We need a target, we need an index, we need the array of course, and obviously if we are having these particular numbers, we need to store them, right? We need to store them somewhere. So we need like a temporary data structure to store that as well. So these are the things that we need, right? And obviously we need an output array. So let's do that. Let's say that we have a result which will consist of your final answer, right? And what does your recursive call needs? Your recursive call needs an index, because you need to choose whatever element is present at that index. You need to have a target to check if it is reaching 0 or not. You need to obviously have the array, obviously, and you need to have a temporary data structure which will consist of all the elements in that particular iteration. So let's say that is ls. Okay, that's all we need, right? That's it. So okay, so what was our base condition? What was the base condition? So the moment we say, okay, we have explored this particular tree, this particular path where I have chosen like the first element for the first time. We have chosen 1 at the first time. We have chosen 2 at the first time. We have chosen 3 at the first time, and we have formulated the whole tree out of it. What can we say? We have completed all our options. We have exhausted all our options. The moment our index reaches 4, okay, the moment our index reaches the length, the moment it is equal to the length of the array. What can you say? That it is obviously the end. Okay, so you need to consider it as done. So that will be your base case. So if my index is equal to length of array, then you can say return from here. But before returning, what do you need to check? Before returning, what you need to check? Before returning, you need to check, right? That is there any combination that is summing up to the target, right? You need to check that. So how can you do that? You'll say if my target becomes 0, at any point my target becomes 0, where my index is equal to the length of the array, then consider that particular combination in my answer. So how can we do that? We can say, okay, res is the output result, right? So we'll say include that in res. So res dot append whatever numbers are there in the temporary data structure, that is ls. So now one thing is there, because you need to consider all the combination, I mean all the elements in this particular combination at this particular time, you'll have to consider its deep copy. So in Python it's done like this. If it's done, you return. Okay, any time your index is equal to length of array, that will be your base case. You return. Okay. After that, what do we need to do? So basically we need to consider all the elements, right? How can we do that? We'll say, okay, and how we'll choose that element? First of all, how we'll choose that element? We were seeing this, right? We were seeing this here, right? That the moment we were getting an element that is greater to the target, okay, if it is greater to the target, we were not considering that. How will it result to our resultant target? If we include that element in our combination, its sum will obviously exceed the target, right? So we do not need that. So what is there? It's basically a condition. The condition is if the element at that particular index is less than or equal to my target, then only consider that element, right? So how can we consider that element? We can like add it to our data structure, our list, our temporary list. So we'll say ls dot append okay. Now the moment we considered a particular element, what did we do? We went ahead and did the recursive call, right? We called the recursion again. So we'll say ls.append array.index. You have included that element in your data structure, in your list, and you'll call the recursive function. You'll call the recursive function on index. So before moving ahead with the other indexes, you are considering it that particular index only, right? Because you have infinite supply of that particular index. So you say the recursive call will go on for that particular index only. If you can include that element again, then obviously you'll include it, right? So the same thing. So you'll include that element, then that particular index. What else? Target. So now you are not looking for the target. What are you looking for? You are looking for target minus array of index, right? Now you're looking for this, and obviously this remains the same. Array remains the same, ls remains the same. So this is your target, right? This is your particular this is your particular recursive call that you need to make. Right now, when you were already done with this particular subtree, let's consider this subtree, right? When you had exhausted all the possibilities for this particular combination 2 comma 2 comma 2, what you had to do? You had to go back, right? You had to go back. You went back and then you tried for this particular combination 2 comma 2, right? So when you are doing that, what do you observe? You obviously need to pop back that element, right? So 2 comma 2 comma 2 is there. right? So if you have included one element, if you have to trace back, what you'll do, you'll have to pop before you move ahead, right? So obviously you'll pop it. Now you pop that element. Okay. Okay, done. So if this condition is not satisfied, what do we need to do? We need to basically move ahead and go to another index and try it, right? In this scenario, we did it, right? 2 comma 2 comma 2 comma 2 did not yield us the answer. So we moved ahead to 2 comma 2 comma 2 comma 3, right? So yeah, that's it. That you have to do. You moved ahead to one index ahead, right? So that will be recursive call of index plus 1. And obviously target, if you're not choosing it right now, if you're just moving ahead, what you'll do, you just moved ahead, right? You moved ahead, your target remained the same here, so you did not have to do that, and like consider that, and you said okay, index plus 1 and the target remains the same because you did not include it. So, and obviously the array and the temporary list remains the same. So this is your recursive function. This is the implementation of the question, and yeah, this will definitely give us the answer. So yeah, this is done. So guys, we'll be coding it up here once so that we can see if it is getting submitted or not. So obviously I will write the same code that we discussed right now. For the recursive function, we need index, target, array, and the temporary list. Then we check the base case. If the index is equal to the length of array and if the target is equal to 0, then we append that list, right, temporary list, because that is consisting of our answer, one such combination which results to the target. Then we checked, right, if that particular array in the element at that index is less than or equal to target, then what did we do? Then we included it, right? So we included, after including it, we called the recursive function again with the same index and the new target. And then finally we have to pop it back again, and at the end we have to call the recursive function again for the next index. So yeah, that is pretty much about it. And now once this is done, we need to call the recursive function with the starting with the index 0, right? So we'll do that, and the target as target and the array as the given candidate array, and a temporary, an empty list which we are temporary data structure. Then at the end we return the result. Let's see if it is getting accepted. It's getting accepted. So let's try to submit, and submitted. So guys, that was it for the combination sum video. We'll meet again in the next video. So all the best.